Okay, here we go. 9-2, angles and arcs as rotations. Hopefully you have this template. I think it would be easier for us to have the conversation. It will happen faster with these nice pictures on the paper. First thing I need to tell you is, from here on out, when we're talking about angles as rotations, is that when we go counterclockwise, that is considered to be a positive rotation. So when we go clockwise, that is a negative rotation. So that's something to think about. The next thing to think about is sort of estimating a rotation, how far it's gone. So like last year in geometry, I don't know how often you really thought about sort of angles that were bigger than triangles, but that's what we're going to be doing here. So we're going to start at this point because you can see where this arrow goes, and here is an angle. So the question would be like starting to think about, well, what is angle AOA prime? Now we're not in the business here to put a protractor on this, so this is approximately 225 degrees, just to think about it. And hopefully that makes some sense, because I think you all know that this straight line has 180 degrees in it. We're going a little beyond that. Okay, so then here's the next one, angle BOB prime, which is going a little further, so it's going to the 180 position, and then it's going 90 more, so that's 270 degrees. So you just need to start becoming comfortable with like dealing with angles. Here's a different one, going in a different direction. So this one is angle COC prime, and if you notice, then this one's going clockwise, and the intention, without putting a protractor on it, is that this would be approximately negative 240 degrees. And hopefully that makes a little sense. This is not on the traditional XY axis, but that would be 180 plus a little bit more. Okay, so there's some vocabulary. Initial and terminal sides of angles. So basically, the initial side is the ray where it starts. I'm going to just be real simple here. And the terminal side is just the ray where it ends. And so if you just look at these examples here, I'm just going to use an I for initial and a T for terminal. This guy begins here, so that's my initial side, and it ends here, so this is my terminal side. Initial side, terminal side, pretty straightforward. This would be my initial side, terminal side. So you just want to start becoming somewhat comfortable with that concept. Okay, another thing that we're going to want to be able to do is classify angles by quadrants, and so that would require, of course, that you know your quadrants. You've probably been taught different ways to remember them. I think one of the easiest, if you struggle with this at all, is to just draw a big C, and as you draw your C, drop the quadrants behind it. So this would be quadrant 1, 2, 3, 4. Quadrants 1, 2, 3, 4. And soon it's going to matter to us what quadrant an angle is in. So this is something you want to definitely become comfortable with. So if we look at this particular angle, hopefully it's clear to you. Oh, quadrant 1. Look at this angle, quadrant 2, quadrant 3, and then this guy wraps around to quadrant 4. So that's pretty easy, hopefully. Okay, then there's these other angles that are referred to as quadrantal angles, and basically this is an angle in standard position whose terminal side lies on one of the axes. So basically, and let me just be clear about what the heck standard position means. So standard position is always starting with an initial side in this position. So basically, if you think of your X and Y axis, you'd be kind of looking out at the positive axis. So that would be standard position, and this is going to become very familiar. Okay, so quadrantal angle then is basically going to have terminal side on an axis. So then this first one, hopefully would feel comfortable, is 90 degrees. This next one is 180 degrees. And finally, this guy right here is 270 degrees. Okay. Hopefully your paper you can see these little arrows better than you can see it on this smartboard right now. Okay, this is something that you're also going to want to understand, and that is the concept of coterminal angles. And so basically coterminal angles are angles in standard position having the same terminal side. So they are basically angles that start from the same place, standard position over here, and they end at the same place, but they take a different path. So if you notice, this first angle is going counterclockwise, and we're being told that it's 300 degrees. And this other angle is going clockwise, and it is negative 60 degrees. And in the end, they both end up at the same two terminal side. That's why we call them co-terminal, because they share a terminal side. And hopefully that seems pretty straightforward, knowing that there's 360 degrees in a circle. And one way to think of it is thinking of wheels. Basically, I mean, you can think about spinning around a bunch of times. Like in this first situation here, we have this angle it's like doing a donut, going all the way around once, and it's going a little bit further. So if I were to tell you that this was 430 degrees, say, not use a protractor here, and I were to tell you then that this is 70 degrees, there is a simple fact that's going to be true because they're co-terminal, and that is the following. If x and y are co-terminal, it will always be true that the difference between x and y is going to be some multiple of 360. So if I look at this first one here and I say, well, what's the difference between 430 and 70? Well, 430 minus 70, check this on your calc, is 360. So this k is just allowing it for to be another multiple, because maybe it's a bigger multiple. In this case, if you wanted to think of k, the k is 1, because 360 times 1 is 360. So this next one, if I tell you that this crazy angle here that's spinning around not once, but it's coming around again, and then it's coming around again, if I were to tell you that that is 870 degrees, and then if you notice this other one, it's going the opposite direction, so it's going to be negative, and if I were to tell you that was negative 200, and I wanted you to confirm, yes, that those are coterminal, what you would want to do is check what their difference is. So if I take 870 and I subtract negative 200, I get 1080. And so the question is, does 360 go into 1080? And it does. If you want, you can check it on your calculator, and it goes in 3 times. So in this case, if you're thinking about kind of this k thing, k would be equal to 3. Okay, one last one over here. Maybe you're already getting it, but this angle that's spinning around, this negative angle is, I'm going to tell you, is negative 400. And this other angle here that's a positive angle is 320 degrees. I'll let you determine if I'm telling the truth here about them being coterminal. Okay, just a couple quick examples and then that will be it. In 1 and 2, each case, which quadrant does an angle of the given measure lie? So really what needs to happen here is you just need to start having sort of a sense of what's going on with angles. And if it helps, I'm just going to draw myself a little x and y axis here. So if I'm thinking about 200 degrees, I'm going to start here and I'm going to start going around. I'm going to say, well, there's 90, there's 180. So here's 200's coming along somewhere, and the question is it here or am I going further? Well, the reality is when I get to this point here, when I get to this axis, I'm at 270. So then I just say, oh, okay, I can tell you where that is. That would be in quadrant 3. Okay, what about something like negative 40? Well, if I want to think about negative 40, then negative means I'm going to go counterclockwise, so negative 40 I'm going to drop down here, and clearly it's less than 90 degrees, so I'm stuck here in quadrant 4. Now, if you wanted to think about the coterminal angle for this, if you wanted to get rid of that negative sign, what you could do is what I like to call put a wrap on it. So instead of being at negative 40, if I want to put a wrap on it and get to the same place, well, one wrap is 360. So if I take negative 40 and I add 360, I get to 320, which is in quadrant 4. Okay, find the angle of smallest positive measure is coterminal with an angle of the given measure. So if someone gives me 790 and says, hey, what's a smaller angle, the smallest positive angle that will get me to that position? I like to think about it as taking wraps off. Clearly this is above 360, so if I take one wrap off, sort of unwind the angle, if I take 790 minus 360, I drop down to 430. Oops, I'm still over 360, so I'm going to take another 360 off, and I bring myself down to 70. So 70 degrees would get me to the same place without going around so many times. Now, if instead I'm given an angle that's a negative angle and I want to get to a positive, I'm going to do the opposite. I'm going to put a wrap kind of thinking in the opposite direction. If I add 360, I will get to the exact same terminal ray if I were to use 260 degrees. And just to sort of visualize that one, think about negative 100. So here I go, negative 100, here's negative 90, so say it's about here. Hopefully, after thinking about this a little bit, you understand that now if I'm going the other direction, here I go 90, 180, and a little shy of 270 would be 260. So sure enough, I end up at the same terminal side, and they are called coterminal. Woohoo! So your job now is to go to mathexcelforschools.com and do the homework.